Now I'll just introduce Mark Thompson Brandt, our session host for the day. Mark is the Senior Conservation Architect and Urbanist at MTBA Associates, and he's a leader of the Zero Net Carbon Collaboration. And Mark will be introducing our panelists for today. And I also want to just remind everybody that on your event app, Socio is our event, the app that we're using for the program today. You can go to this particular breakout session, scroll to the bottom of the page, click on Ask a Question, and we'll try to feed those questions into Mark throughout the panel. And then we'll, about halfway through, we'll stop again, and Mark will be hosting the Q&A for the panel. So thank you very, very much for being here. I'm glad you returned from lunch, and take it away, Mark.
Thank you very much, Andrew. Welcome, everyone. I hope everyone's had a chance to have some lunch and relax. Perhaps not get too relaxed. The post-lunch show is always a risk that way. I'm just going to jump right in. The Socio app that Andrew mentioned has a lot more information about our panelists. This is our subject today. And we have a great segue coming out of the pre-lunch panel where towards the end, those of you who are in this room will remember that we talked a lot about existing buildings and the importance of paying them a little bit more attention. Andrew mentioned the Zero Net Carbon Collaborative for existing and historic buildings that I'm involved with. Thank you to them as well today. So I'm going to quickly introduce you to all the panelists, and then they will each do a presentation, one after the other. I'll finish, and then we'll get into the interactive portion of the event. Ralph Dinola is Chief Executive Officer with New Buildings Institute. It says Washington, D.C. there. That was just to trick you to see if anybody knew that he's actually up in Cascadia, where he should be. Rod Yo is a principal with Dialogue, design and engineering firm out of Vancouver with offices around North America. And Paula McAvoy is a co-director of sustainability at Perkins & Will, and she's based in Atlanta. I'm based in Ottawa, Canada, so I think we have the continent pretty well covered. And just before I hand off to Ralph, I just want to re-emphasize something that's been coming up pretty much all day. The business case is really important. The 3 Ps, people, planet, profit, is real, that there are real returns on all 3. But I think what we're all learning very rapidly is that net zero carbon can actually pay back. Amory did an amazing job of talking a little bit just sustainability and self-paying back. Carbon as well. And you know, the UN is telling us that we really have to kick it up with existing buildings. We need to increase the amount of deep green rehabilitation we're doing 6-fold right away. And you know, it's been over half a decade that the International Panel on Climate Change has been telling us it's all about existing buildings. So I just wanted to re-emphasize that you're in the right session right now, dealing with existing buildings. Ralph, can you take it away?
Sure. All right, thanks a lot, Mark. And hopefully this thing is working. Or not?
We just have to get your session up.
Okay.
Just take a sec.
Everyone enjoy lunch? Good. Okay. All right. So I am okay. Is that better?
Yeah.
It's like, okay, I could be like a nightclub singer here. All right. Well, so getting started. Hopefully, you know of New Buildings Institute. NBI is a nonprofit. We're based in Portland, Oregon, not Washington D.C. Although we do find ourselves there. We've been operating for over 20 years now, really focused on advancing energy policy, research, design guidance, and our 3 program areas: zero energy leadership, and market development, building and program innovation, and then advancing codes and policy. And I think a lot of this discussion today has given me a lot of thought about what we need to do on codes and policy. So, clearly the existing buildings question is something we need to focus on. In the US, every year we only basically build 1% to 2% of the building stock, right? So the other 98% remains. And by 2030, we're still going to have 75, 80% of that building stock. So we need to focus on existing buildings. Years ago, I think back in 2011, we did a study. I was involved in a study in a previous position on what we were considering the greenest building, right? The environmental value of building reuse. And that study found that clearly, if we're thinking about near-term carbon savings, we've got to reuse existing buildings rather than demolishing them and building new. And I think we know that zero energy buildings have low operating carbon intensity, but that construction carbon is something we really need to focus on. So, of course, building reuse is key. And we know existing buildings can be problematic. We have a lot to contend with when we're looking at existing buildings, but we also know that they usually, especially pre-war, were designed for a lot of the kind of strategies that we think about today. So when we look at those buildings, they were designed for daylighting. There were actually specs that show, looking for 6-foot candles at the desktop surface as kind of a code requirement. But you see here, designing for deep daylight penetration and not having electric lighting. So, we should be thinking about how those strategies can be incorporated into new buildings, but also how do we have that happen again? Also, natural ventilation, right? So the ability to open a window, go to daylight, and so it's I think good to look at these historic photos and see what's going on there. Anyone have any idea what that is? Has to do with this. So it's a paperweight. So kind of it's interesting thinking about vestigial elements that still exist today, right? We had paperweights because if you use a fan or you open a window, your papers are going to go flying. It happens in my office. But it is interesting to think about how it became an artifact rather than a functional thing. And in fact, probably the cigarette lighter is more functional in this particular case than the paperweight. But that transition, right, from those buildings that we just saw to these buildings, right, these post-war buildings where increase in indoor smoking and hermetically sealing buildings is a problem, right? So now what we're dealing with is these buildings are becoming historic, and we've got to contend with that. And as we saw with Ed this morning, these buildings, the tall buildings, are the ones that are most energy intensive and most carbon intensive in cities. So what is the solution for these buildings, and especially these historic buildings that we're going to be dealing with now? And then there's the run-of-the-mill building, right? And what's happened to those? So all over Portland, buildings were retrofitted with this solution, right? Which was to put in HVAC, neck down the daylighting, and so what's the opportunity there to restore those functions? So we got to look at the building stock. We've got a lot of commercial buildings, and most of that energy use, or at least half, in residential. But when we look at the commercial building stock, 4 building types really rise to the top: office, mercantile, education, healthcare, and really thinking that that's half the energy, more than half the energy that we need to deal with existing buildings. So we've been focusing on zero energy buildings at New Buildings Institute, and we see this growing trend of zero energy. We know that we can decrease energy use in these buildings by 50 to 70%, right? So we've got the data. We can get the UI down to 18 in verified buildings. And the retrofitted buildings, so we've got about 20% of the buildings, 20 to 25% of the buildings that we're tracking are existing building reuse, and we see that those are low energy buildings too, right? So it's achievable in existing buildings. And it's also achievable at a competitive cost. So again, tracking the data and seeing that we can have among the lowest square foot costs for building reuse. And what we're seeing is trends in technologies. So using radiant for distribution rather than air, and using ground source heat pumps and other air-to-air heat pumps as a strategy as well. So the predominant technology we're seeing integrated. So how do you assess these buildings? We've got a software that was funded by EPA. This is the next step after Energy Star Portfolio Manager, called First View, where we can actually, just with the Energy Star data, we can actually do a analysis of a building, an energy signature with an energy end-use breakdown, and we can then look at a whole portfolio and say which are the buildings that are really driving energy use in a portfolio. So this is a municipal portfolio. And then we can look at individual buildings and say, well, where are the high energy intensity buildings? Are there anomalies in those end uses that we see? What's the total consumption and the most challenging projects? And then we can start identifying targeted retrofits or targeted auditing. And we can also identify candidates for zero energy, right? So we've used this for California schools to identify buildings that could be retrofitted to zero. And we've developed this guide, which you can download, a Community Strategic Energy Management Implementation Guide that helps municipalities through this process. What do we hear as kind of the real issue? The real issue is buildings do not get retrofitted unless there's some reason for that, right? So thinking about, and RMI put this nice slide together, what are the triggers that we can use, right? So point of sale, point of lease, refinancing, et cetera. We need to be thinking about when those acts happen and when there are triggers. And Amory talked about this too. Where are those intervention points? So, there's kind of differential durability of systems in buildings. So we should be thinking about where those systems interact or come together and when those retrofit opportunities happen, and focus our activities around those. So we should be thinking about the process and how we engage people, and what are the practices that we need to use, the strategies, and then specific products that we can integrate, the technologies. I think people jump to technologies probably more rapidly than thinking about process and people. Here's a simple thing that we should be thinking about. I think a lot of existing buildings go through gut rehab, and people think they have to be gut rehab. But if we think about, can a building get to low energy with low intervention, right? So you don't have to move people out of the building. You don't have to go through that expense. So thinking about assessing the opportunity for low, medium, high intervention as a way to get after most of the building stock is a good strategy. And I think lastly, I'll just talk about the Grid Optimal initiative. So this is a new initiative from NBI focusing on building grid integration. And this is kind of the next thing, right? The balancing of efficiency with renewables and storage and grid harmonization. So we want to look at the strategies for lowering the building's total energy load and then shifting the load and making the load more flexible to what the grid needs. And so this is not necessarily efficiency, but it certainly is a strategy for carbon reductions for buildings. And so we see these kind of 4 different approaches. What are the permanent strategies we can build in that we saw like with those historic buildings? How can we shift the peak? Can we be dynamically responsive? And then can we dispatch storage? And so there's a kind of some core strategies we should be thinking about for all retrofits. And there's a big movement afoot, especially in California, but now we're seeing nationally toward electrification. There's this 2030 pathway from SoCal Edison you can look at, but electrifying buildings, again, another big thing that we really need to think about when we're doing retrofits. So I think I'm just going to kind of skip through this and give our other panelists a chance to speak as well. So please, if you take a moment and look at NBI's website, we have a lot of resources to support existing building efficiency, and look forward to the discussion.
Thanks, Ralph. It's just going to take us a couple of seconds, Rod, to bring up your presentation.
Okay.
Ralph, I'm doing a session tomorrow where that guidelines for communities that you were talking about will be probably spoken of in that. So thank you very much for that. Go ahead, Rod.
Okay. For people who haven't been up here, there's a countdown timer that's really quite distracting, but I'll try not to look at that. So I'm Rod Yo. I'm a mechanical engineer with Dialogue. I have a lot of slides, so I'm going to go through them really quickly. So at Dialogue, one of our vision is to meaningfully improve the communities and the well-being of the communities we're in and the environment. And for us, the environment is a key part of that. We have offices in, how's your geography? Vancouver, Edmonton, Calgary, Toronto, and here in San Francisco. So, and we're one of a handful of Canadian firms that have actually signed on to the AIA 2030 Challenge for carbon neutrality. So, one of the things I was asked to talk about quickly is triggers, and Ralph mentioned it. I'm lucky to be from a city that's very forward-thinking. City of Vancouver wants to be the greenest city in the world. That's sort of their mandate. So in January 1st, 2015, they actually implemented a energy upgrade part of their building code. Vancouver is unique in Canada. It's one of the only cities in Canada that has its own charter, and they are allowed to create their own building codes because of that. So they added an energy upgrade component to their city building code. So it's triggered by renovations. It's a stepped trigger system. The level of upgrade required is contingent on the extent of the renovation. And I was involved in a lot of the industry consultation and feedback before they implemented this code. And what helped was they already had similar upgrade triggers for fire and life safety, structural and non-structural seismic, and accessibility. So just a quick, really quick, this is from their the energy code. So for a rehabilitation project, if it's a voluntary upgrade, you kind of can see the level of upgrades you need to do, F1 for fire life safety, but the energy is at the bottom. That was added in this 2015 edition. So if you have a major renovation, you need to upgrade your energy to an E4 level. Then you go down and you look at what an E4 is. It's a list of energy upgrade sort of components, and you can pick from a list. So just another upgrade trigger is a change of major occupancy. If you're getting an existing building rezoned from an office building to residential or vice versa, you need to go through another checklist and get upgrades triggers. Another one for additions, so there's different paths for horizontal additions versus vertical additions. Not a lot of vertical additions because 30 years ago, not many people designed their building to add more floors, but there are some. So that's the quick City of Vancouver example. And I'd be happy to talk about it more. And I think actually Patrick Enright from the city is here, might be in the audience. I'm not sure. He was giving another presentation before lunch. So he'd be a good person to talk to as well. Now, case studies. This is a project that we are doing at Dialogue for the University of Calgary. So the original structure is a library tower built in 1968. Tower was initially 6 floors, expanded vertically in 1971 with an additional 6. And now they want to get it up to 22 stories. It's got a concrete superstructure, precast cladding, curtain wall. Now, the key for us was the University of Calgary is very interested in sustainability, wanted to get to net zero, wanted to get to zero carbon, but also the building systems, the envelope and the mechanical electrical systems are at end of life, so it's a good time to do it. So one of the first things we did, working with Trans Solar, we did a climate study. We did solar analysis for the site, modeled sort of the energy, the solar potential on the site, solar radiation on the each face of the building. And you can see in Calgary, we actually had more solar potential than in Berlin, which is where Trans Solar is from. And then we modeled each facade, the amount of solar potential on each facade. So you can see, which makes sense. Calgary's a bit north of here, so with southwest and southeast facades have high potential. The northwest facade has very little potential. And then we also looked at the climate data. So this is the range of outdoor temperatures in sort of Calgary, anywhere from -30 Celsius up to about 30 degrees Celsius. So it's a pretty wide range, 60-degree range through the year. And the other key is that we modeled and looked at the diurnal temperature, which is the difference between the daytime and nighttime temperatures in summertime. So you can see even when it's pretty warm out, you get a daytime temperature of +30, it got down to below 15 degrees Celsius at night. So what does that mean? There's a high potential for passive night cooling and flushing. So the result of all that analysis is, there's a high solar potential during the winter. There's a substantial diurnal temperature swing, which I mentioned. And Calgary's pretty dry, so it's got pretty low humidity levels during the summer. So what that meant was our design takes into account passive solar utilization of sun for the various facades, active solar applications on roof and facades, natural ventilation, there's a bit of a wind through that site, passive cooling by night flushing, high benefit from the use of thermal mass. As I said, the core of the building still the large concrete structure. No humidity problem in the summer, very little. So we could use evaporative and adiabatic cooling. But the other thing we looked at, dialogues and integrated firms, as I said, architects and engineers. So we looked together. One of the major things we're doing at that building that's a little out of the ordinary is we're actually putting a double skin on it. So we looked to analyze the double facade versus a single facade. And we didn't just look at it from a energy point of view, we looked at it from a comfort point of view as well. So it's really hard to see, but the scatter plot on the top left is with the double facade, bottom right, bottom left is single facade. And you can see the comfort envelopes with the single facade. There were lots of times and hours where we're outside the comfort envelope, but with the double facade, we're almost entirely within it without any mechanical cooling. So that sold the university on the options. Once we'd done that, now we looked at various mechanical system options with airflow, bringing in outside air from the exterior of the building, displacement ventilation systems, radiant panels in the exterior. And then looking at zoning the perimeter zones and interior zones separately so that we transfer air from the perimeter zones to the interior zones. And then part of our study was the shading of the double skin facade, trying to make sure that we reduced glare and direct solar penetration. And here's some renderings of the daylighting studies we did. And some just renderings of the design. So the building's fully designed, it's going out for tender right now. And the good thing, Calgary had a big budget, so we were able to stick within it. Sorry, slide got screwed up. And another example I want to give is we're currently working on 3 buildings for the federal government, and because they're supposed to be security clearance requirements, I can only refer to them as building 1, 2, and 3. But before they actually go through the implementation process, and they actually have a very detailed process for deciding what to do in each building. So they study and model the baseline and 4 bundles for each building. The baseline is the carbon emissions from the existing building. We're just talking operational carbon. They don't actually look at embodied carbon yet, and we're talking to them about that. Option 1, they have minimal departmental standards, which is about 24% below our National Energy Building Code in Canada. Option 2 is a bundle of measures that are cost neutral from a life cycle basis of 25 years with the baseline. Option 3 is kind of a shoot for the stars option. Anything the design team can think of that will reduce carbon and energy use is we look at in option 3. And then option 4 is kind of the bundle of measures they actually implement, which is a combination of things from option 2 and 3 that provides the maximum carbon reduction with a reasonable life cycle cost. And based on that, this is one of the buildings we looked at. Again, we can't give too many details, but so the final sort of things we're implementing are envelope upgrades up to R20. R20 doesn't sound like much now from a new building, but this was a building from 1960 something, and it was probably R5 at the time. So R40 roof, triple glazing, and then we have a DOAS, dedicated outdoor air system with heat recovery, and then VRF, variable refrigerant flow system with radiant heating and perimeter and condensing boilers as backup. And the predicted EUI is about 101 kilowatt hours per square meter per year, which, for those of you familiar with kBTUs per square foot, divide that about 3. 58% of the savings versus the pre-retrofit estimated, and about 75% GHG savings versus pre-retrofit. Building 2, I think this is in Toronto. It's a larger building. Again, similar things, R28 walls, board insulation, R40 roof, triple glazing, DOAS with heat recovery, fan coils for heating and cooling, heat recovery chiller connected to a ground loop geothermal field. And then again, predicted EUI of 60, which is about 20 in kBTUs per square foot, which is pretty low. 70% reductions, 80% GHG reductions. And finally, building 3, this one was a little harder, but R14 walls, R35 roof, double glazing. VAV distribution, it's got a very large building. If you look at this square footage, it's 911,000 square meters, which is almost 10 million square feet. So it's a very large building. Had a central VAV distribution system tied to district cooling system. We're looking at predicted EUI of 117, about 77% energy and GHG savings. And that should be it.
We're going to do some more case studies from Paula.
I don't know if this is on. There it is.
Yes, there you
really
go.
have to talk right into it.
Okay. So a couple more case studies, and then we'll finish off. Go ahead, Paula.
Hi, thanks for inviting me here. I'm really having a good time today. I'm Paula McAvoy. I'm from Atlanta, the Atlanta office of Perkins & Will. So what I wanted to do is go through two of those other buildings, not the biggest of the big one, just kind of medium that are everywhere. They're so prolific in Atlanta and in so many cities. This is going to show the things that we tried for both of them. One is a building that we did a few years ago for our own office, and the other one is one that's just now completing. So the processes were the same. I want to talk about the sustainable benchmarks that we set for each project, the site selection, transit, how that played into the site, the reduce, reuse, recycle, and how that impacted not only just the materials, but a lot of other things we discovered about the buildings. Of course, energy and carbon, water and the impact of water on energy and carbon, the material selection, and then finally the living labs that both of these buildings are going to be, and lessons learned from one to the other. They are, oddly enough, both on one version of Peachtree Street, because everything is in Atlanta. So 1315 Peachtree Street is Perkins & Will, Atlanta. It's a LEED Platinum building. It was certified when you might remember this, when it was certified, it was the highest certified building in the entire world for 4 days. I remember that, yeah. We also were after the 2030 Challenge, Sites Pilot Certification. We wanted it to be a living lab. We wanted to see what we could do with our precautionary list. We wanted to explore different ways of working together, meaning in this case going from cubicles to team seating and teaming. And then we wanted to explore resilience goals. 1280 West Peachtree Street is very close by, and I was going to be very subtle and just put 1280 West Peachtree until I realized that the owner's or the occupant's name is all over the slide you're about to see, and the owner is actually in the audience. So, hi, Chip. They also have the goals of LEED Platinum, WELL Gold certified, carbon neutral. They're doing factories as a forest, so this is interface. Factories as a forest and carbon neutral are very important ongoing pursuits for Interface and how they design their products and how they manufacture around the world. They're also very much involved with biomimicry. They wanted the building to be all showrooms, so not just a separate showroom and then office space. They wanted to explore different kind of work choices because they were bringing people from a number of different types of office buildings. And then again, resilience goals. This is, on the left, the map of Metro Atlanta, which is a big sprawl. There's a perimeter highway around it. And these two buildings are 2 blocks away from each other, pretty much right in the center of that perimeter highway. It's a really great location, and we both picked it for the same reasons. The first one is that it's very close to a major transit hub, and the transit hub has plans for even being more of a transit hub and a more densely developed site. There's also a very big arts center. The High Museum of Art is just next door. It's right in between both of us. There are other museums in the area, and Interface and Perkins & Will both like the idea of being in a neighborhood associated with design and with arts. When we moved into the building, we had fully 35% of our people who either commuted to work by transit or carpooling or walking. And now there are bicycles and birds and limes and scooters and one-wheel things and everything flying down the sidewalk. So transit is a very big, very popular mode of transportation in Midtown. So part of the first reduction that we looked at was how many square feet do we need and what are we doing with all that anyway? And when we were designing our offices at Perkins & Will, we were going from cubicles into essentially benches. So we knew that that was going to take away some of the individual workspace that we'd gotten used to. And if you've been in an architect's office, you know that most of that space was piled high with drawings and spec books and a whole bunch of stuff that we probably didn't need. But still, we had to go through a weaning process and get rid of all that stuff so that we could move in. We budgeted probably a 30% growth rate. So we were moving in with about 200 people, going to probably 240 to 260. So we had built in additional seating spaces. We also had shared spaces, so big conference rooms, a few smaller conference rooms, virtually no offices, some shared spaces, open spaces, outdoor spaces. By the time Interface came along, a couple of years ago and started programming them, the idea of going to benches seemed pretty obsolete. So they wanted to look at better work choices so that some people would move in with a desk assigned to them, and a lot of people would move in with nothing assigned to them, and just find the best place for them to work. So there could be a number of teaming places, there could be lounge places, there are a lot of booths and coffee bars and just casual places, outdoor spaces. So whatever somebody felt like working in that day. And they're working through now, they're just moving in this week and last week, and they're working through how that goes when people find out they don't have a desk and they are free to use the whole office as a desk. This is 1315 Peachtree, so Perkins and Will, Atlanta. It was a 1980s building. It was virtually empty when we bought the building. And this is a process photo in construction. It has a glass wall facing west that has been removed at this point. But this is the only one that I have that really clearly shows that north side, which is pretty well glazed. It's got really nice light from the north side. It's also got a fully glazed east side on the opposite side. It's got cast-in-place concrete structure. Floor plates are about 10,000 square feet, and there's virtually no outdoor site. There's a little bit that in this photo is a driveway, like a horseshoe driveway, that takes you straight into the front of the building. It's also got 3 levels of parking in the existing condition, that 1 is at grade and 2 step down underneath that building. We wanted to virtually clear the entire thing except for the structure and the glazing. We did a lot of testing on this and found that the north side glazing was actually pretty good. It didn't get direct sunlight. There wasn't a lot of solar heat going through it. East was a little bit worse, and then west, of course, was deadly for us, so we knew we had to do something about the east and west elevations. The rest of it is a clear span concrete of 65 feet. So when we demolished the interior, we were left with this, which was very nice open studio space on the right. We were also left with everything on the left, which was piles and piles of carpeting and ceiling tiles and file cabinets and desks and insulation and everything you could imagine. And we took the 3 levels of parking that were below the building and actually staged the demolition materials, identified it, palleted it, and then sent around a PDF to all the nonprofits in Atlanta. And they were able to come and take whatever they wanted from the building. We ended up getting rid of almost $1 million worth of goods to all of these other nonprofits. Thank you. Here's the cool thing that it did, though. It started another nonprofit called the Life Cycle Building Center, which now their business is to go to businesses who are going through deconstruction and demolition, take the building apart, take the things back to their warehouse, which they now own, and have a whole company that does this for a living. 1280 West Peachtree Street is this charming one. It's a little bit older. It was originally 1960s. They had gone through an extensive renovation in the 1980s where they covered the entire building with EFS. They changed out the windows to those really dark, bronzy, reflective windows. There's still punched openings. There's not a whole lot of insulation in the rest of the building except for the EFS system. This is the east on the left side and the north elevations. The back 2 elevations are blocked. They're lot line elevations, so there's a condo tower on one side and an apartment building on the other side directly butting into the building. They're also about 10,000 square feet, cast-in-place concrete, east-north exposure, and again, minimal site to do anything. So we were looking at ways that we could incorporate rainwater capture or PV panels or anything like that, so very limited for both of these. The inside was nothing really to write home about. It was very carved up, lots of offices, not much daylight, hadn't been upgraded probably since the 80s. And we decided to do the same thing. Let's take it back all the way to the structure, keep the concrete, see what we have left. We kept some of the sprinklers and ended up rerouting it. All the HVAC had to be changed out. And then we started looking at the windows, and they weren't very good windows to begin with. The glazing was failing, the ceiling and gaskets were failing. So we decided to take those out as well. Jumping back to Perkins and Will, 1315, we knew the west facade was going to be the worst. So the first design problem we had was solved for the west facade. And we went through a whole lot of different schemes about adding operable shading devices, operable screens on the exterior, shading on the interior. And on the end, what we came up with is a combination of everything, which knocks probably about 94% of the solar heat gain out of the building. Some of the design strategies we looked into and ended up incorporating, of course, the west exposure. We have a trigen plant on the roof, which consists of natural gas turbines, which burn natural gas to feed an adsorption chiller, and it produces electricity, hot water, and building heat for the building, heating and cooling for the building. We also have a radiant heating and cooling system. It's the MATS by Becca that you see in blue at the bottom of the slide. They circulate water through a series of piping, just tiny calipers of piping that are up against the ceiling and the perimeter walls. And then we have a 7.2 kilowatt PV array on the roof that we really wanted more as a demonstration. We didn't know what was going to be built around us. We modeled for only one side of the building to actually be able to be in sun for the next few years. So that was about all we could manage to put up there at the time. It runs probably the lighting for the building. The numbers were 58% source energy reduction. It's hard to figure out the exact reduction because we have a power plant on the roof. So we're making our own electricity from natural gas. So source site is really a hard one for me to get clear on that. The 64% greenhouse gas reduction was coming through burning natural gas rather than relying on Georgia Power's electricity, which was basically coal-based at the time. 54% reduction in energy costs, 67% lighting power density reduction, and because of the adsorption chillers, 0 ozone depleting refrigerants for cooling. For our interface for 1280 West Peachtree, we were looking at the same thing. These diagrams are a little washed out, but we were looking at insulation and radiation, solar radiation for the site, and found that there could be some on that northeast corner of the existing roof. But when we went there, we decided that that was probably a better roof, a better location for other purposes, and we wanted to actually occupy that portion of the roof. So there's still a chance to put solar on the high roof that we built on top of this, but at the time it didn't make a lot of sense to do solar on the roof. That really directly conflicts with Interface's goal of being carbon neutral and doing climate take back. So we wanted to talk about the portfolio of buildings and factories as a portfolio, not just as an individual building and an individual factory. So Interface is starting a program of tracking all of their performance across the globe, and this building will factor into that one. So we'll be able to display and to talk about the story about how Interface as a company is performing. Some of the things that we designed in here, limited solar heat gain because we did have just the north and the eastern exposure. East is on a downhill side. There's a hill climbing up to Peachtree Street on the eastern side. Also buildings and trees. So we didn't think that that immediately needed shading on it. We have convective heating and cooling by the chilled beams that you see in the ceiling. LED lighting. 1315 Peachtree installed with some T5 fluorescent lights and LEDs because at the time we thought LED was too expensive and the fixtures weren't where we wanted them to be, and now you don't even think about fluorescent, it's all LED. They're also going after LEED v4, so the controls for LEED v4 are more stringent and more energy saving so that outlets actually are switching off when people are not using them. And some of the predicted results that we're seeing right now, this hasn't been submitted for LEED or WELL or anything. They're just now moving in. So 68% site energy reduction, 35 kPTU per square foot energy use intensity. And part of this was because it's not just an office building. They've also got practically a data center, a small data center on site that's running all of the data for a lot of the company. 48% energy cost reduction and a 50% lighting power density reduction. Water was very important. Both projects used cisterns. Ours was 10,000 gallons buried beside the building so that it's not visible. We have a water feature that tells the story of it. But I think that's one of the things we would have liked to have changed, and we used the water for flush fixtures and irrigation. Interface decided that they wanted water as part of their major overall story because they are a manufacturer. So the cistern is on display, it's bigger, it does the same things running flush fixtures and irrigation, but it's very visible and housed in the parking garage beneath their building. So it's actually going to be part of the tour path. For 1315, the materials portion came from keeping the structure, keeping the concrete that we had, not tearing any out, not adding very much at all to it. We did add some carbon fiber reinforcing to the underside of some concrete beams. Minimizing the use of extra materials. We wanted the interior FF&E to be minimal, authentic. We didn't layer materials upon other materials, concrete floors, exposed concrete. We tried to do the precautionary list screening for toxic materials, and it's LEED 2009 materials credits. Whereas by the time we get to 1280 West Peachtree, the structure, again, was the same, where we kept the concrete, the same kind of carbon fiber reinforcing, minimizing the use of superfluous materials, so there's a lot of exposed structure, a lot of exposed new structure. The interior FF&E was reclaimed, was sourced from manufacturers with environmental project declarations and cradle-to-cradle certifications, following LEED V4 and WELL. And the lessons learned from 13-15, we recommissioned it in 2014 and 2015 because it was going to be on the AIE National Tour, and had found that there were very big gaps in the performance due to things like meters being installed incorrectly, meters not being installed at all, wiring being crossed. But it was just taking that extra year to comb through the entire system and figure out what was wrong and correct it. We've also reconfigured the layout. We didn't need that extra growth room at all. In fact, we consolidated and ended up leasing one of the floors to an entirely different tenant. So now we have 3 tenants in the building. And then ongoing user education. We think that we've been there 5 years and everybody knows it, but we have so many new people that we have to continually tell the story. This is the before and after photos. Interfaces, see, giveaway, right? If I'd said 1280 this whole time, you would have known by now. They're moving in this month and still in the process of doing it. So they've completed the commissioning and the IEQ testing. They've designed the building so that it is also reconfigurable, from the demountable partitions to the size of the rooms to the locations of the furniture. And they're building in a very robust change management plan so that people who are moving from these different locations, from offices and loft spaces, understand how the building works and know who to call if you've got a question about how the building works. The last thing that we did was shroud the building with a polyester film that actually does provide some shading on the north side and on the east side, and it shows the factory as a forest with interface employees operating inside that. It also really directly refers to the High Museum, which is white, and this is the before and after of those two.
Thank you, Paula. So I'm going to try and go quite quickly through mine, partly because today's entire conference is doing a great job from my perspective and touching on a number of the points that I wanted to make, and partly because we're running out of time. American author Storm Cunningham says that what he calls the restoration economy, I call the low-carbon economy, is the greatest new growth frontier. So what we're actually talking about isn't just sort of battening down the hatches, it's actually clean growth for pretty much all of the developed world. It's interesting that we're only cluing in now. We've been recycling materials and pop cans and newspapers since like the 60s. We've been doing car sharing since like the 80s. Why are we only really getting serious about recycling buildings now? I don't know. Cunningham says in the US, the reinvestment, this is a reinvestment-driven economy, $1 trillion annually in the US with $100 trillion in inventory. Now, to contrast Ed Masria's numbers, which included the whole world, including the developing countries, in the developed countries, particularly, these are from Architect Magazine referring to the US, next 10 years, about a third of dollars spent in the building industry will be new construction, and about 2/3 will be rehab. So that's quite a change from decades past. The following 10 years, 10 to 20 new and 80 to 90 rehab. So we have really a massive thing happening. And I'm not going to get into this slide, but this is an article from last year that I wrote that talked a little bit about the mid-century period, mid-century modern period. The 3 decades after World War II, we built in the Western world the same amount of building as we did in all of recorded time prior to that. Think about it, in 3 decades. So, and guess what? That stuff's coming up for life cycle enhancement now. And what did Ed say? 75% cheaper to do your green rehabs at the time that you're doing life cycle changes anyway. We have a coming tidal wave. Rod didn't show the picture of his building 3, so I will. We happen to be working with them on this one. And he did talk a little bit about the federal government program, so I won't get into that. Tied into that, it started with a pan-Canadian framework for clean growth of the economy and the environment. It came down through the Canada Green Building Council, which became one of 3 worldwide first on for the carbon program. And now committees of Parliament are actually making specific recommendations to take into account the net carbon emissions avoided through adaptive reuse of existing buildings. So, in fact, there is at least one federal government that's actually trying to act and lead and really making a difference with their own portfolio. Tools. I'm going to go through very quickly 2 types of tools. One is a plethora of new guidance tools. You've been hearing some from the previous session that we had here in this room before lunch. This is one that our firm was asked to do, a national guideline document for sustainable rehab of buildings in Canada. It's online now. One of the great things about it is it got all of the provincial, territorial, and federal governments online with the policy on it. There's lots of great stuff in it. I'm not going to take the time, but it's really something worthwhile. What I consider it as, it's the sort of base foundational document of knowledge for both the professional and the amateur building owner doing their own thing. And then from there you supplement with whatever of the technical tools that you're going to be using, whether it's life cycle assessment or energy modeling, whatever it is. It has an extensive case study section, which really goes into a number of things. This is a building, well, we wrote the document, so we got to throw one of our own buildings in as a case study. And I just wanted to focus on this one, because this embodies quite a bit. So this building was actually a historic building, not just any old existing building. Had the highest possible heritage designation, and that included both interiors and exteriors. So we really had a challenge from a sustainability perspective, and it really forced us to work as a team to really integrate a lot of the number of the things that Amory was talking about at lunch. And we were doing a lot of we were doing a lot of things like developing hybrid HVAC systems using both what was there, refurbished of course, and new, together in harmony to get our better numbers. Things like only heating and cooling areas where people are. We didn't quite go to the extent of those chairs that Amory showed us, but same principles, right? Most important, you really have to know your building, your existing building. If it's a total gut, it's a little different. But if you're not doing a total gut, you really need to understand the building and understand what's going to be the accumulative impact of all of your interventions. Without getting into all of the sustainability features that went into it, you'll see the dark print at the top. Those items are kind of your everyday standard. Let's throw this in, let's throw that in. You're bundling. And at the bottom, it has to do more with looking at historic buildings, older buildings, and some of the things that we've been talking about today. So it earned the highest rating under the Green Globe system. And it's really a conversation between the existing historic building and the new building across structural glass atrium. The second guidance is online tools that are proliferating now. We've found 3 or 4 in Europe. There's a few in North America. I'm just going to highlight one of them. Association for Preservation Technology is developing something called OSCAR, which stands for Online Sustainable Conservation Assistance Resource. And version 2 is coming out actually next month, debuting at the 50th anniversary conference in Buffalo. And it is both an informational resource as well as a design tool as well as an educational tool. Much more interactive, bring your own building to the party. Here's some more resources that I suppose we can leave up, Andrew, while we have a bit of a discussion. So we do, believe it or not, have a few minutes left. First of all, panel, thank you. I think I'm just going to kick it off, Andrew. If you have anything from Socio, bring it in, but I'm just going to kick it off. I think Ralph and I talked a little bit about more general things with just a couple of sort of reference to case studies. The others talked more specifics about specific projects. And I think the idea is that as a community, we are developing tools, we are communicating more to each other, and I think it's really important to do that. It's one of the things that I've heard so far throughout the day, Andrew, that we need to be more collaborative, we need to get our act together. And I think organizations such as New Building Institute, Rocky Mountain Institute, Zero Net Carbon Collaboration, I think these are some of the ways that we're doing it. I think that when we're looking at specific case studies, we're looking at that great combination of, I'll call it pre-ASHRAE buildings, where architects understood how to make their occupants comfortable without mechanical systems and elaborate artificial lighting systems, combining the knowledge and wisdom from that with our new knowledge and wisdom of technologies. And I think it's that interface, that interaction of those two fundamental differences that are really where we're heading for optimization and zero carbon. Any of the panel care to talk about that?
I will address the thermal comfort issue because that's one of our actually key selling points to clients for existing buildings. A little bit contrary to what you said, some of the buildings, built in the 70s and 80s actually aren't that comfortable the way they are with single glazing. So we were able to sell triple glazing in Calgary, not just from an energy point of view. It's going to be more comfortable near a window with a triple glazed window, and it's not just thermal comfort; it's acoustics too, right? So we build a lot of high-rise residential in Vancouver, adjacent to very high arterial routes. So the traffic noise is an issue. So we sell our clients on the fact that if you put triple glazing in, you can sell you're more likely to sell, well, in Vancouver you can sell a condo without anything, but you're more likely to sell a higher priced condo if you can tell them that it's actually quieter in there, right? So there's other things other than energy that you can sell to clients.
We've got time for just a couple of questions before we break. And I've got a mic. I think we've got another mic right over there. So raise your hand and we'll run over to you and you can ask a question quick.
Too many turkey sandwiches for
Oh
lunch.
yeah, too many turkey sandwiches.
I was just going to, I guess, add to this dialogue. One of the reasons we're focused on municipal buildings and municipal fleets is this, leadership by example opportunity. And, the sad reality of being a bureaucrat in a municipality is you're probably in an existing building that hasn't been renovated for, 20 years or more. You're not able to walk the talk. And of course, it's the new construction projects that get all of the funding and get upgraded to be LEED, gold, platinum, what have you. So we're really trying to help municipalities using First View, using our community SEM approach to basically look at their whole portfolio and then try and align what they're doing with their building stock, with their climate goals, and then they're able to talk about that with the community as well. So it's improving the conditions for those employees, and it's also being able to walk the talk, in their community. So that's kind of one of the things what we're driving change through that process.
Any last question? Yes, right down here. And there's a mic coming right behind you there.
Paula, following up on what Ralph just said, when you were doing those two buildings in Atlanta, did you have any differences in how you met the local building code or the local energy code in renovation versus what that would have been with new construction? Was it easier? Was it more difficult? What did you find?
I think the energy code wasn't the difficult part of it. The systems were so unique to that area. You don't do radiant heating and cooling in the southeast where it's hot and humid. The buildings had been designed without operable windows. For regenerative design, our biggest stressors were likely to be particulate matter, pollen, carbon from cars. So we didn't really want a whole lot of operable windows. The code officials tend to see what all that stuff is and go, okay, if you've got the engineer who says it works, pretty much. What we did have a problem with was the water, because they had never done a whole lot of reclaimed water in Atlanta. So we had to go through a whole lot of education about here's a cistern, potable. It doesn't mean we're going to drink it. So that's a big part of it, holding hands, walking people through the educational process, even on code officials.
Let's do a couple more quick questions, and then we'll take a break.
I'd like to get your feedback on an idea. Here in California, we're seeing renewables come on really strong, and we're looking to be at 60% renewable power by 2030. If that's the case, could we just fuel switch and get rid of natural gas in our buildings as a way to quickly scale up our emissions reductions without doing all these retrofits?
Yeah, I in our database, not that many of the zero energy buildings have gas use. Mostly they're residential. Mostly it's domestic hot water. We know there are heat pump technologies to do domestic hot water, especially in multifamily scenarios. So that choice of it. So one of the things we're challenged with codes is federal preemption. You cannot basically a jurisdiction cannot require more efficient equipment than is the national standard, but designers can choose that equipment, right? And so you could choose to heat pump technology over gas-fired equipment. You should be able to demonstrate cost effectiveness in your work, and we do think that with this grid optimal initiative, we need buildings to be flexible and grid interactive. If they achieve those goals, which it's clear that California achieves goals in advance of the targets, we're going to have an even worse problem with the duck curve, right? So the challenge of that belly of the duck in the midday. And so having a building that can be grid responsive and use energy when the grid needs that, and then supply energy on other times. So I'd say yes. Every designer has a choice to make, and every owner has a choice to make in terms of choosing electrification.
And I'll just add very quickly to that solar, wind, a lot of the renewables are not necessarily ideal for tight, high-density urban conditions where there is not a lot of place to put them. And of course, that density, on the other hand, is very good for reducing carbon and energy. So there is a bit of a trade-off depending on the site and the location.
So again, I just want to quickly address that. From a technical point of view, it's a good idea. What we're struggling with is the cost of electricity versus the cost of gas. In BC, our electrical grid is actually 93 to 97% carbon-free. It's all hydro. But it's even with our cheap power, it's still 3 times the cost per unit energy for electricity versus gas. So we're having a hard time convincing people to fuel switch.
Great, thanks. We've got one final question, and Larry, you're on. Was it you? It wasn't you. I thought was there somebody else's hand who was up? I just put you on the spot for nothing. I'm very disappointed. Okay, we'll do that. Come back to me in a little bit. We're going to take a little break right now. We want everybody in this room to check out our exhibitors. We've got 18 companies and organizations with some really interesting solutions and products. and ideas. So please check them out. Have a little bit of coffee if you need that to wake up after the turkey sandwich. And we'll see you back here in this room for the design track at 2:30 on the dot.
And Andrew, I'd just like to thank my colleagues for accepting my invitation and coming and joining us here. And of course, for the audience, thank you very much.
Great.